Next topic I am going to explain about is derivation. So derivation is nothing but we have to derive a string from a grammar. How we can get the string means by sequence, that is simultaneously we can apply some production to the start symbol. That transforms the start symbol into string. So finally we can get a string. String is nothing but the lowercase letters. So we can get the string from a grammar is applying a sequence of production that transforms the start symbol into the string. So here start symbol is E. For this E, how we can derive the input? That is nothing but derivation. Then we have continuously applying some productions to the start symbol production. Finally, we can get the string. Derivation proves that a string belongs to the language defined by the grammar. Suppose if we receive or accept derive the string means then this input is accepted by this grammar. Otherwise, suppose it is not possible to accept this string means it is not accepted by this, not possible to derive means it is not accepted by this grammar. So that is the second point. Derivation proves that the string belongs to the language defined by the grammar or not. Next one, parse tree can be constructed with the help of the derivation. How we can derive with the help of this derivation, we can draw the parse tree here. So that is the next point. Parse tree can be constructed with the help of the derivation. Parse tree is a graphical representation of a derivation. Parse tree is nothing but it is the diagrammatic or graphical representation of a derivation. At each step, each and every step in a derivation, a production is applied to the leftmost non-terminal. Then the derivation is called leftmost derivation. For example, here in this leftmost derivation, e plus t, there are two variables are there. But we are applying, first we have to check which one is the leftmost variable. Leftmost variable is e. So for that e, we have to apply the production here. That is nothing but leftmost derivation. A production is applied to the leftmost non-terminal, then the derivation is called leftmost derivation. And rightmost derivation is vice versa. That means from the right side we are substituting the terminal symbol. A derivation in which the rightmost non-terminal is replaced at each step. It is called rightmost derivation. Here out of this e plus t, right side rightmost non-terminal is t. So for this t, we have to substitute the production here. That is rightmost derivation. We will see one example here for derivation. This is the production. E tends to e plus t or t. T tends to t asterisk f for f. And f tends to within the parenthesis e, and a is the one more symbol. Here a is the terminal symbol here. So we have to derive the string or input. We name it as input or string. So this is the input. We have to derive this input from the start symbol. A plus a asterisk a. So start symbol is E. For E, there are two productions. E tends to E plus T or E tends to T. Suppose if we are taking E tends to T, it is not possible to derive the input because for T there are two production, asterisk is there. But in our input plus is also there. So that's the reason we are choosing the first production. E tends to E plus T. So for this E, a leftmost derivation definition already we know. We have to replace the leftmost variable by that e production. Here the leftmost variable is e. For e there are two production, e plus t and t. Suppose here if you are choosing e plus t again means two plus symbols it will come. For e, suppose if you are choosing e plus t means e plus t plus t. There are two plus symbols, but in our input there is only one plus one more asterisk. That's the reason we have to choose the second production, e tends to t. So e is replaced by t production here. E is replaced by t and plus t it will come as it is. Again here out of these two symbols, the leftmost non-terminal is this t. So here we have to replace this t by either T asterisk F production or F production. Suppose if you are choosing T asterisk F production means here asterisk will comes first. Asterisk. T is replaced by T asterisk F means asterisk will comes first. But in our input plus comes first. So that's the reason we are choosing F production. For T we are choosing the F production here. T is replaced by F and this plus and T come as it is. Again for F there are two different production. In our input there is no parenthesis, so don't choose this production. We have to choose A here. So F is replaced by A plus T. Now out of these three symbols, A is a terminal symbol, again plus is the terminal symbol. Next non-terminal symbol is T. So now we have to replace this T by T production. T there are two production, T asterisk F and F. Suppose if you are choosing F means asterisk does not come, but in our input asterisk is there. So we have to choose the T asterisk F production here. T is replaced by X. So out of these three symbols, T is the first leftmost non-terminal. So T is replaced by F, similar to the previous steps, and F is replaced by A. Again here there is only one more non-terminal symbol, that is F. So that F is replaced by A here. This is the leftmost derivation. We have to, here this string is accepted. We are deriving the production from start symbol and this input is derived here by using leftmost derivation. Similarly, we can do the same thing for rightmost derivation. So in rightmost derivation, E tends to E plus T. The rightmost terminal, non-terminal symbol is T. So this T is replaced by T. There are two productions, F and T asterisk F. So in our input asterisk is there. So we have to choose T asterisk F. Suppose if you are choosing F production means asterisk it is not possible to derive. So T asterisk F is there. For T is removed by T asterisk F. Again out of these symbols F is the rightmost non-terminal. So F is replaced by A. Again for this T is suppose if we are using for T asterisk F means 2 asterisk will come. So that's the reason we are choosing the second production. T tends to F. T is replaced by F. Again F is a non-terminal symbol, rightmost non-terminal. So F is replaced by A. So we can remove this production from the given grammar. So here out of these three, the rightmost non-terminal symbol is E here out of all the symbols. So E is replaced by E. For E there are two production. E tends to E plus T. Suppose if you are choosing E plus T means plus it will come two times. So that's the reason we choose the second production. E tends to T. E is replaced by T. T is replaced by F. Again F is replaced by A. So this is the input. Here we are deriving the input here. Finally we derive this input A plus A asterisk A by using leftmost derivation as well as rightmost derivation, by using both derivation. Derivation there are two types, rightmost and leftmost derivation. By using both leftmost derivation and rightmost derivation, we are deriving the input from the start symbol. Next one is parse tree. How we can draw the parse tree? It is a diagrammatic representation or graphical representation of a given grammar. So E is the start symbol. First we are taking the E here. E tends to E plus. For the same input we are draw the parse tree. So E tends to E plus. Suppose if you are choosing E tends to T, plus won't come. That's the reason E tends to E plus T. Whatever we did here, the same thing here. The E is replaced by E plus T. Again here this E is replaced by T. T is replaced by F. Suppose here if you are using again E plus T, E is replaced by E plus T here. Here also if you want to use E plus T means plus it will comes two times. So in our input there is only one plus. E is replaced by the second production, that is T here. Here suppose if you want to use T asterisk F means asterisk will comes first, but in our input plus will comes first. So T is replaced by the second production F. For F, the F2 production, first one contains parenthesis, but here there is no parenthesis. Directly we can use the second production. F is replaced by A. So A. In parts tree, the leaf node always contains the terminal symbol. If we reach the terminal symbol here, and plus is also here, terminal symbol, no need to do anything here. And T is replaced by T asterisk F. For T, there are two productions. Suppose if you are choosing F means asterisk will not come. So that's the reason first production we have to choose. T asterisk F, T is replaced by F and F is replaced by A. Asterisk is a terminal symbol. Again for F, F is replaced by A. Now we are checking the leaf nodes allowed A plus A asterisk A. We are deriving the input in the parse tree. So this is the diagrammatic representation or graphical representation. This is nothing but the parse tree. There is one more example. In this example, by using the leftmost derivation, input contain open parenthesis. So start symbol is S here. If you are choosing A, there is no more derivation here. So we have to choose the first. S tends to L in the parenthesis. Now for L, there are two production. Suppose if you are choosing S again, so S tends L is replaced by S, S comma yes. Again for this S, we have to replace the S by A. For these S, in the next step, we are replacing this with this L because here there is one more bracket. So within the bracket, L is there. So we have to choose this production. So for this L, L comma S again we have to choose, and this L is replaced by S. So L, there are two production. It is not A. So we have to choose this production. And for this S, L is replaced again by S. For this S, S is replaced by A here. So L is replaced by S, S is replaced by A. Here S is there, S is replaced by A. The same thing, but we can do it from the rightmost side. Here we are checking from leftmost derivation. Here we are seeing take the values from the rightmost derivation. So L comma S, rightmost variable is S. So S is replaced by parenthesis, within the parenthesis L. Again L for two productions are there. If you are choosing S means A comma A, it is not possible to derive. So we have to choose L comma S. Again out of these symbols, S is the rightmost non-terminal. So S is replaced by A. This L is replaced by S and S is again replaced by A. So we can repeat the same steps here. So L is replaced by S, S is replaced by A. By using both leftmost derivation and rightmost derivation, we are accepting or deriving the input here. For parse tree, S is the start symbol. So for start symbol within the parenthesis, L is there. L is replaced by L comma S. Again this L is replaced by S, S is replaced by A. Similarly here, S is replaced by parenthesis L because in our input there are two parentheses. So for this L again L comma S, L is replaced, the same step is repeated. L comma L is replaced by S, S is replaced by A. Here S is replaced by A. So this is the parse tree for this input. So this is the derivation by using leftmost and rightmost derivation, and what is the parse tree we discussed here. Thank you.